All right. So on your note card, you'll write a section called double angle identities. And you'll write the sine of 2x equals 2 sine of x cosine of x. And there's 3 different cosine ones. Write them all down. The first one, the cosine of 2x equals cosine squared of x minus sine squared of x. Not a plus, because if it was plus, then it'd be 1. But a minus is cosine 2x. The cosine of 2x is also equal to 2 cosine squared of x minus 1. The cosine of 2x is also equal to 1 minus 2 sine squared of x. And the last one is a tangent. The tangent of 2x is equal to 2 tangent of x over 1 minus tangent squared of x. Okay, so that is the double angle identity section of your note card. We have one more thing to add to your note card, but not today. We'll do that on Monday. And then on Monday, we'll also tweak your note cards with making sure we have linear velocity, law of sine, law of cosine, angular velocity, Heron's formula. Angular velocity, I don't think we need too bad, but how to find those things. Arc length, sector area. We'll make sure all those are on your note card in case don't have them on the board in here when you take the test. Okay? So, all right, here we go. Let's say we have the cosine of 90 degrees. You already know what the cosine of 90 degrees is. So you will know every answer before you even start these problems. You're just showing me how you can work through identities to get an answer that you know you have already. Which you'll say, boy, that's stupid that we have to learn this. But it's trig identities. We learn these trig identities. So the cosine of 90 degrees. What is the cosine of 90 degrees? What do we know that it is? 0. 0. And so I'm going to use one of my trig identities to figure it out. So I'm going to use cosine squared of x minus sine squared of x. Okay, so the cosine of 90 is really the cosine of 2 times 45 degrees. So x is going to be 45. Okay? So we're going to do cosine of 45 squared minus sine of 45 squared. So it's going to be square root of 2 over 2 squared minus square root of 2 over 2 squared, which is going to be 2/4 minus 2/4, which is 1/2 minus 1/2, which is 0. And 0 is our answer. Like I said, you're going to know all these answers before we ever start. Let's do the sine of 240 degrees. which is the same as the sine of 2 times 120. So x is 120. Now what's our sine formula? Well, the sine of 2x, we are told that it's 2 sine of x cosine of x. So we take 2 sine of 120 cosine of 120. The sine of 120 is square root of 3 over 2. Yes. The cosine of 120 is negative 1/2. If I multiply all these together, this 2 and this 2 cancel. So I got 3 times negative 1, which is negative square root of 3 over 2. If you look on your unit circle at 240 degrees, the sine of 240 is negative square root of 3 over 2. Okay? We're just proving it using a trig identity. Okay? Tangent of, let's go 300 and, let's just go tangent 300. There we go. Which is the same as a tangent of 2 times 150. X is 150. Now the tangent of 2x, I told you on your note card, is equal to 2 tangent of x over, I think it's 2 tangent of x, right? Over the tangent one I can never remember. 1 minus tangent squared of x. All right. So it's 2 tangent of 150 over 1 minus tangent of 150 squared. Now, does anybody know the tangent of 150 off the top of your head? Tangent of 150 is in second quadrant, 30 degrees above the 180 horizontal line. So it's going to be one of those fraction ones that they hate dealing with. So the tangent of 150 is square root of 3 over 3, and it's going to be negative. So your numerator is going to be negative 2 square root of 3 over 3. Your denominator is going to be 1 minus square root of 3 squared is 3. 3 squared is 9, which really is 1/3. So you have negative 2 square root of 3 over 3 over 2/3. Now, how do I get rid of a complex fraction? So we're going to multiply top and bottom by 3. Those cancel. So you get negative 2 square root of 3 over 2. Your 2's cancel. And you get negative square root of 3. So after all that work, we have proven that the tangent of 300 is just negative square root of 3. Looking on your note card, or not in your note card, your unit circle, yep, that is correct. Do maybe 2 more, and then we'll be done. The cosine of 3 pi over 2. Well, the cosine of 3 pi over 2 is the cosine of 2 times 3 pi over 4. Because if you take 2 times 3 pi over 4, the 2 and the 4 cancel be 1 and 2. So that's how you get there. So you take this and take half of it, and that goes in your parentheses. This is your x. Okay? So the cosine of 2x, we know, is 3 different things. So let's do 2 cosine squared of x minus 1 this time, just to do it. So it's going to be 2 times the cosine of 3 pi over 4 squared minus 1. What's cosine of 3 pi over 4? Looking at your unit circle, 3 pi over 4 is square root 2 over 2. And we're squaring that and subtracting 1 from it. So negative times a negative is a positive. Square root 2 times square root 2 is 2. 2 times 2 is 4 minus 1. The 2 and the 4 cancel, be 1 and 2. 2 over 2 is 1. 1 minus 1 is 0. Is the cosine of 3 pi over 2 0? Yes, it sure is. One last one. The tangent of 2 pi over 3. The tangent of 2 pi over 3 is the same as the tangent of 2 times pi over 3. So your x is pi over 3. So the tangent of 2x formula is 2 tangent of x over 1 minus tangent squared of x. So 2 tangent of pi over 3 over 1 minus tangent of pi over 3 squared. What's the tangent of pi over 3? Well, it's at 60 degrees. It's one that we want to use because it doesn't have fractions, so it's square root of 3. What's the square root of 3 squared? 3. So it's 1 minus 3. 1 minus 3 is a negative 2. 2 divided by negative 2 is negative 1, so it's negative square root of 3. And tangent of 2 pi over 3, you can look and see, and yep, it's going to be negative square root of 3. So, page 193, 1 through 8 all. Okay, so this should take you 15, maybe 20 minutes tops. Then you'll have a half an hour to work in your semester projects. On Monday, we'll go over these 8 quick, and then we'll do the second half of 3-5. That'll take you, and you should have another half hour-ish, I would guess, to work on your semester projects. And then Wednesday and Friday, Wednesday you should have maybe a little time to work on semester projects. And then Wednesday the 7th, you'll have time to work on semester projects. So you should have time to work on semester projects here. A little here and a little there.